The laws of physics put constraints on us when we start building distributed systems. They basically dictate that those systems have to be eventually consistent. There's just no way to avoid it. Now what we want to do is we want to understand the definition of eventual consistency better so that we know what it really means. So here's a very basic definition. Eventual consistency guarantees that in the absence of new updates, all accesses to a specific piece of data will eventually return the most recent value. What this is basically saying, if we look at it from a real world example, like our restaurant, is if in our restaurant we wanted to know how many tables were currently occupied. There's a number of ways we could get that information. We could obviously count it ourselves, but one of the things that we could do is we could go to all the servers and ask them how many tables are currently occupied. Now, if we do that, some of the servers will probably have just been in the dining room and they have seen exactly how many tables that are occupied, and they can probably provide that information for us very easily. Other servers, on the other hand, may not have been in the dining room for the past few minutes. They've been doing something else. And so they may be unaware that somebody has just come in the door or somebody has just left. So they will give us an answer, but that answer will be incorrect. What will end up happening is we'll end up with a bunch of different servers all giving us different answers. Now, what if nobody else comes into the restaurant and nobody else leaves the restaurant for some period of time? In other words, if there are no new updates to the information, then what will eventually happen is each of those servers will eventually go spend some more time out in the dining room, and they will see, oh, that table that I didn't realize was occupied is now occupied, and that table that I thought had people at it, they've now left. So eventually what will happen, as long as nothing changes, is all of the servers will reach a point where they know exactly which tables are occupied and which tables aren't, and they can give us the same answer. We will reach a state of consistency. But that only applies as long as there's no new updates. If there are continued updates, then what's going to happen is you're going to get back into that situation where some of the servers will have out-of-date information and some of the servers will have up-to-date information, and so you'll continue to get conflicting results. That's what it means to be eventually consistent. In order to reach a state of consistency, you have to stop all updates, at least for some period of time in order to reach that level of consistency. Now, eventually consistent models break down into many different forms. Each of these forms have different trade-offs. There's the basic eventual consistency, which we've already defined. We also have causal consistency. This means that causally related items will be processed in a common order. For example, if A causes B, then A will always be processed before B. So two things that when one thing causes another, it always has to be processed in that order. We also have a more strict form, which is called sequential consistency. In that case, all items have to be processed in a sequential order, regardless of whether they're causally related. Now, these do have trade-offs. As you go to more strict forms of eventual consistency, you get into different types of trade-offs. Like with sequential consistency, if you choose that, you eliminate the ability to parallelize. Because it requires that every event be processed in a specific order, you have to complete the first event before you move on to the second event. It means you can't parallelize that at all. And that's a problem, obviously, if you're trying to build something that is really scalable. So each of these different consistency models has different trade-offs, and we have to be aware of that. There's a bunch of other ones. We haven't listed them all here. You're more than welcome to look up the other ones if you're interested. We've just given you a few to show you that there are different options and they do have different trade-offs. Traditional monolithic architectures are usually based around strong consistency. They use a strongly consistent database like a SQL database or something like that in order to provide that consistency. And much like with the other consistency models, there are trade-offs when you do that. And we'll discuss in more detail what those trade-offs are.